You hear the term machine learning, and what comes to mind? Probably, super complex algorithms, maybe some data scientists in a lab. But what if we thought about it differently? What if it's just a completely new kind of tool? Well, that's exactly what we're going to dive into today. We're taking inspiration from Jeff Proz's fantastic book to see how machine learning gives us this revolutionary way to solve problems that honestly, regular old computer code just can't handle. And you know what the best part is? We're going to tackle this using the author's own philosophy. He asks, how would I want this explained to me if I was just getting started? So look, we're not going to get bogged down in all the heavy math. No calculus, no linear algebra, I promise. The goal here is simple, to give you a real gut-level feel for how this stuff actually works, and maybe more importantly, why it's totally changing everything. All right, so let's start with the big idea, the most important thing to get. Machine learning, it isn't just a slightly better, faster algorithm. No, it's a whole new way of thinking about how to get a computer to do something useful. Okay, to really get this, let's try a little thought experiment. How would you, right now, teach a computer to know if a photo has a cat in it? The old way, the traditional programming way, would be to write a bunch of rules, right? You'd say, okay, computer, if it has pointy ears, and it has whiskers, and it's furry, then it's a cat. But you see the problem, don't you? You'd immediately find a cat with floppy ears or a weird angle where you can't see the whiskers. Your rules would break instantly. And that's where the old way of doing things just completely hits a brick wall. And this really lays it all out, this tale of two problems. On one side, you've got something like calculating a mortgage payment. That's a classic algorithm problem. There's a perfect, precise recipe, and if you follow the steps, you get the right answer every single time. It's predictable. But then you have our cat problem. That's not a recipe problem. It's a pattern problem. And the new way, the machine learning way, it throws the recipe book out the window. Instead, it says, hey, computer, I'm not going to give you rules. I'm just going to show you thousands and thousands of pictures of cats. Eventually, the computer starts to learn the pattern, the very essence of catness, all by itself. So here's the absolute key takeaway. Machine learning gives us a superpower. It lets us solve a whole class of problems that are super easy for us humans, like spotting a cat, but have been ridiculously, almost impossibly hard for computers. This isn't just a small step forward, it's a total fundamental shift in how we even approach problem solving with computers. Okay, so if we're teaching these machines, how do we actually do it? Well, it really boils down to two main styles, two big schools of thought when it comes to machine learning. First up, we've got something called unsupervised learning. And I gotta say, this Lego analogy is just perfect. Imagine dumping a giant box of mixed up Legos on the floor and telling your computer, okay, sort these into piles that make sense. You're not telling it put all the red ones here or all the square ones there. You're just telling it to find the patterns, find the groups. It's all about discovering hidden structures in messy data completely on its own. Let's make this real. Pretend for a second you own a store. And this table here is a tiny snapshot of your customer data. You've got their income, some kind of spending score. Just looking at it, can you spot any obvious groups? I mean, it's kind of tough, right? Now imagine you had a million rows of this stuff. Impossible for a person to sort through. And that's where the machine just shines. You can feed all of this data, income, spending, whatever else you have, into an unsupervised learning algorithm, and it will just crunch through it. It does the one thing our brains are not good at, finding those subtle, meaningful patterns hidden in a massive sea of numbers. And boom, look at the result. All that messy data suddenly makes sense. It's not just data anymore, it's actual intelligence you can use. The algorithm found 5 totally distinct groups of customers. You've got your high-income low spenders, your low-income high spenders, and everything in between. Now you know exactly who to send that fancy marketing email to and who might respond better to a discount. That's the magic right there, turning chaos into clarity. All right, so that was unsupervised, where the machine is on its own. The other big school is called supervised learning, and here the roles are reversed. We're the teacher. This time we're giving the machine a huge data set, but with one key difference. All the answers are included. It's like a giant cheat sheet. We show it 10,000 photos that are explicitly labeled cat and 10,000 labeled dog over and over until it finally figures out the difference for itself. And believe me, you are using this technology all day, every day. That spam filter in your inbox, it works because it was trained on millions of emails that humans already labeled as spam or not spam. Or think about the post office. How does it read those messy, handwritten zip codes on letters? Supervised learning. It's all about learning from a ton of examples with the right answers, so it can make smart predictions on new stuff it's never seen before. Okay, now we get to the really cool stuff. The stuff you see in the headlines. Whenever you hear about some mind-blowing new AI breakthrough, chances are you're hearing about a very specific, very powerful type of machine learning called deep learning. So, what is deep learning? Well, it uses these really complex systems inspired by the human brain, called neural networks. And they are just ridiculously good at finding the tiniest, most subtle patterns in pretty much anything. Images, sound, text, you name it. This is the engine. This is what's powering everything from self-driving cars to the real-time translation on your phone. So what's actually happening under the hood? Let's say a deep learning model looks at this photo of a sea turtle. It's not seeing a turtle in the way you and I do. Instead, it's breaking that image down into thousands, even millions of little pieces. Tiny patterns of pixels, the curve of a flipper, the texture of the shell, the specific shades of green and brown. It recognizes all these little features that it learned were associated with turtles from all the training images it saw. Then it puts all those clues together and makes a prediction, usually with a crazy high confidence score. And what's just wild is that this same idea can be used for sound. How do you teach a computer to hear a chainsaw in a rainforest? Well, you do something clever. You take the audio file, the sound waves, and you convert them into an image, something called a spectrogram. It's basically a picture of the sound. Now, all of a sudden, it's an image problem again. An image recognition model can be trained to spot the unique visual shape of a chainsaw sound in that picture. It's just a brilliant trick, right? Turning a hearing problem into a seeing problem. And then, of course, there's text. You've probably heard the term natural language processing, or NLP. This is it. It's how a machine can read a sentence like great food and excellent service and know with 99.9% certainty that it's positive. It's how it spots the patterns in spammy emails. It's even how your favorite streaming service looks at the movies you like and says, hey, you might like this other one too. It's all just about finding the hidden patterns in the way we write and speak. Now, I know this all sounds incredibly complicated, and look, behind the scenes, it is really complex. But here is probably the single most important point of this entire conversation. All of this power, it's not locked away in some university research lab anymore. It's not out of reach. It is here, now, and it's available for basically everyone. I mean, think about it. Just a few years ago, if you wanted to do this stuff, you needed a team of PhDs, a giant custom-built data set, and probably hundreds of thousands of dollars worth of supercomputers. Not anymore. That world is gone. The barrier to entry has just completely collapsed. So what does that actually look like for a developer today? Let's take this example of a travel app, right? One that can translate a street sign from a photo. The person building this app doesn't have to invent a way to read text from images. No way. They just make a call to a pre-built tool, a computer vision service, that does it for them. That tool sends the text back. Then they take that text and send it to another pre-built tool, a translation service. And just like that, they get the translation. It's literally like snapping together a few Lego bricks to build something amazing. And these building blocks, these Legos, they have a technical name, APIs, Application Programming Interfaces. You've got companies like Microsoft, Google, Amazon. They have done all the heavy lifting. They've spent the millions of dollars to train these huge, powerful models. And now they basically rent them out, letting any developer in the world plug this incredible power directly into their own apps, usually for pennies. It is an absolute game changer. So that's where we'll leave it. With this one really exciting idea. This world-changing, incredibly powerful technology is now, for the first time, at our fingertips. It's accessible to pretty much anyone with a good idea. So the real question isn't just what can AI do anymore? The real question is, what are you going to do with it? What's the first problem you're going to solve?